Hello, my name is Elizabeth Krizay, and I'll be talking about my research under my advisor, Dr. Rachel Cummings. Our project is entitled NeedleStack, and the primary focus of research is in modeling human browsing online. Why would anyone want to model human browsing behavior? Well, I'm going to bring your attention to a new law that was passed on March 28, 2017, which repealed regulations that protected consumer privacy online. What this law essentially does is allows ISPs to collect, share, and sell sensitive data without your consent. As Colorado Representative Jared Polis explains, this resolution undermines fundamental privacy for every Internet user. Data-driven decision-making is becoming increasingly popular in many fields such as insurance, finance, criminal justice, and politics. And now, ISPs are allowed to sell any of your personal information that they can find. Companies can make decisions about you from information that you never fully chose to disclose. Furthermore, there may be sensitive aspects to your own browsing that you might wish to keep private. And while there are solutions to this problem already in existence, these solutions can often be expensive when done correctly and ineffective when not. What we aim to create in NeedleStack is another solution to this problem of data privacy, but ideally one that is easily accessible, inexpensive, and effective. We aim for NeedleStack to be a program, a type of internet plugin to be exact, that doesn't hide your data from the ISP like a VPN does, but rather obscures your data with noise that's unidentifiable from your own browsing. This noise will consist of randomly generated website requests that simulates human browsing behavior. Your own browsing history will still be available to the ISP, but it will be masked in a sea of similar human-like requests. The end result of this noise is that your ISP or any other company access to your data won't be able to differentiate your own data from that randomly generated by NeedleStack, thus leaving them unable to figure out sensitive information about you. Going back to the name, rather than searching for a needle in a proverbial haystack, ISPs would be left searching for a needle in a stack of other needles. In order to understand the type of model we're proposing for NeedleStack, a brief introduction to Markov chains is necessary, particularly the concept of a state space and transition probabilities. We start at the base level of a stochastic process, which is just a collection of random variables indexed by time which can be discrete or continuous. Now, if a discrete time stochastic process satisfies the Markov property shown on the slide, then this process is called a discrete time Markov chain, or DTMC for short. The Markov property simply explains that the probability of attaining a future state depends only on the present state and not on all of the past states. The entire compilation of states a DTMC can visit is commonly referred to as capital S, which is countable. Finally, the transition probabilities, denoted lowercase pij, is the probability that the process, currently in state I, will transition to state j in the next time step. The compilation of all such transition probabilities is the transition probability matrix, denoted as capital P. We believe that internet browsing can be modeled as a DTMC where the particular actions, like typing and clicking, one can take online comprise our state space. It's important to note that we believe that every web page has a specific and somewhat unique distribution of actions. We also believe, though, that websites in the same type of category will have similar distributions that are hopefully indistinguishable by the ISP. Thus, we hope to model entire categories of websites, such as social network and entertainment. Now, it is very likely that a user may begin in category A and naturally traverse to category B. In our model, the categories themselves can be modeled as an additional DTMC, thus creating the nested part of the model. In order to create such a model, however, we needed to be able to see exactly how humans interact with an online environment. Thus, we designed and implemented a 2-week-long behavioral study that tracked 30 participants' browsing behavior over the course of 2 weeks. The end result of this study is a compilation of numerous crawls online that we were able to fit our model's parameters to. We do have some preliminary results from the study. Here is a rough fitting of our large between-category DTMC. As there are many states, it's not very visually understandable, but I will point out 2 transition probabilities. We can see that a user is more likely to remain on reference websites with an 85% retention probability than banking websites with only a 61% retention probability. Similarly, here is a rough fitting of our social network category. As we can see, a user is much more likely to achieve certain action states, which makes logical sense. Someone online is much more likely to click, type, and change URLs than they are to hit New Tab. We are still very much in the process of tweaking and fine-tuning the exact fit of our model, which is why these results are still very much preliminary. Our next steps will be to focus on cross-validation of the model in order to test its efficacy. Does something like NeedleStack already exist, though? Well, in a way. There are two similar plugins, but they're much less robust than we aim for NeedleStack to be. There's one called Internet Noise, which simulates browsing by searching commonly used words in websites, and another called Noisy, which attempts to add true noise to a user's browsing by following links within a set list of websites. These plugins only create haystacks in which they hide the needle of user browsing. Their simulated browsing looks like real user behavior on the surface, but an ISP or any other company would be able to easily tell the difference. Lastly, VPNs or virtual private networks are honestly a fantastic option for data privacy, but they require you to trust your VPN provider with your data, as there's no privacy from the VPN itself depending on the service you use. Furthermore, VPNs can also be costly and have the added issue of slowing down internet speeds. We believe there should be a fully private, affordable, and effective solution to this data privacy problem, and we believe NeedleStack can be the solution. As our world becomes increasingly connected, privacy is becoming vital in most aspects of our lives. The scope of this model is quite vast and powerful. At its best, this model will hopefully impact current privacy options available. At its worst, however, this model could also allow for more targeted exploitation. It is vital to remain at the forefront of new models and technologies in order to guide the manners in which they will be used and ideally eliminate the ways in which they may be exploited. This model will hopefully garner a better understanding of how society interacts with this new technological world, as well as allow future innovations that can inform the future. Thank you.